Uh, Take a look at this slide and we will see that all of the arithmetical operations that are available within the Python language, and you can see the plus, minus, multiplication, division, power, and remainder. What does it mean, remainder? Remainder, it means that what remains after the division. So suppose we have a number 9 and try to divide it by 3, the remainder is 0. But if we will try to divide it by 2, the remainder will be the 1. So let's try to execute this statement. So let's say that I will erase everything I have written till now, and let's say that A is equal to 9 and B is equal to 9 divided by 2, and try to output B. And what do we see? We see 4.5. But if we would like to obtain this remainder, we need to substitute our division to a different operation. So now we have a remainder of 1. And this operation is very useful when you would like to, for example, separate all of the values that you have stored within a collection to even unknown numbers, for example. And let's get further. Here are the different examples of the operations you can see on the next slide, and you can see that the precedence of the execution of all of the operations depends on the meaning of the operation. So the multiplication, division, exponential operations are executed first, and the addition and subtraction are executed as last operations. So here are the rules of the precedence. The parentheses are always respected. The exponential operation raised to a power, the second one. The multiplication, division, and remainder are the important one, and less important is to additional and subtraction or left to right operation. Take a look at this explanation of the calculation. You can see that here we have a complex formula to calculate the x variable, and we can see that the exponential operation executed first. The second one will be the division by 4, the third one will be multiplication by 5, and only the last operation will be an addition of number 1 to a calculated result. What else can we do here is that I have to mention that we are not necessarily writing all of the Python scripts within a Python file, so that you can start your Python coding by just typing the Python 3, for example, and I can say here as 3 plus or 3 plus 4, and we'll see the result of the calculation immediately here. It means that I have entered the interpreter environment and the interpreter execution process. So everything that I write here will be executed immediately. And how to quit here? I'll just write a quit command from the to our interpreter to get out of the process of analyzing of input data that I insert. Okay, what else do we see here is how can we express loops, and what are the collections. First of all, let's talk about the loops, and as you remember, we have a different kind of loops within our Python environment. We have while loops and for loops. The for is typically an iterator loop, and while loop is a conditional loop. So let's say that I will express a variable a as 1, and while my a is less than 10, I will repeat that a is equal to a plus 1 and print the a variable. Let's take a look and try to execute this script, and what we will see here, we see that we have initiated our a variable by number 1, and then written the loop code that is expressed by a while command, and the condition within the while command, and colon that ends up every structure of a code. That means that everything that will be written as indentation of tab, for example here, will be executed within this loop. So if I will write down, for example, here is finish it, we will see that the loop will repeat only this segment of code, because intention of this print is placed at the level of the while loop and not within this scope. And let's try to execute and demonstrate. And you can see that we have run the operations of addition of A and printing of A every time we go through the loop, and only one time we print the finish it message. And if I will, for example, make an intention here to print, it means for a Python interpreter that all of the 3 statements have to be repeated 10 times. You can see here. So do not forget to take a very accurate attention to all of the indentions that you use within your script. Okay, now how can we improve this code? We can see that I can add, oh no, this operation is not available here. A is equal to A plus 1. The only way that can help me to increment the value of the A variable. So what can be wrong within this script is that this loop can be transformed or can be expressed in the wrong way, so that it will never finish up. So let's say if it will be while A is greater than 1 or greater or equal. And in this time, if I will try to run this code, it will never get out of my loop operation, because A is greater than or equal by than 1, and I will always increment this A and print A as an output, and I will never get the message of finished here. Let's try to execute, and you will see that my number always improved or grows up, and there is no way how to stop the execution except by telling the operating system to kill this process. And I will do this by pressing the combination of symbols of Control C. That means that I would like to finish this process, and I would like the operating system to kill it. So don't forget to pay attention to the condition of the cycles and not making them infinite. Okay, that's the one way of how can we express loop. Another way how can we express loop is the for operation or for statement. Let's say it will be the for the target list and in something. And in this something can be a sequence of elements, and the sequence of elements is expressed as list or an array. Let's say that we have an array of A. Now let's say that it will be array number, and we will express it as number 1, 2, 3, 4, 5, 6, 7, 8, 9. And now we would like to, for each element within an array, we would like to print this element. And let's try to execute this code. And what do we see? We see that all of the elements are printed as an output for our script.